Hey, welcome back to Math with Patrick. It's May 8th, and we have problem number 128 from this Daily Epsilon calendar to solve. And apparently the answer is 8. That's going to be this x variable right here. X is supposed to match today's date. And then x is going to be equal to a, b, and c all added up. Before that, I do see that I have 3 equations and 3 different unknown variables, right? I have this a, I have this b, and I have this c. And so anytime that you have like the same amount of unknowns as the number of equations, you can typically solve for each one of them. So that's my plan. I'm going to take a look at these 3 equations and see if I can do some stuff there to figure out what A, B, and C are. The first thing I want to do is maybe try some elimination. I'm going to take this last equation, A minus C equals 18, and kind of like hold it up to or hold it next to the first one, A plus B equals 5. And I'm going to take this part, A minus C, and try subtracting away an A plus B. So I'll do A minus C, and I'm subtracting away an A plus B. And my ultimate goal here is to eliminate or get rid of this A variable. A minus C is just the same thing as the number 18, according to that first equation. And then A plus B is the same thing as just the number 5. So I can replace this part with an 18 and this part with a 5. And ultimately, by eliminating this A, so A minus A gives me nothing, I do get negative C minus B equals 13. Which I think I would prefer that if I like negated both sides, and I'm going to swap around my variables. I know that I could get B plus C equals negative 13 out of this. And at least I could like match it up to this B plus C and say that this is negative 13. I don't know what A is though, but if I add that A value to B and C, hopefully I would get X. Another thing we could do is compare these ones together because they both have that A variable and that C variable. So kind of like narrowing our search, I know that if I have 2 unknowns and 2 equations, I can solve for both of them. So maybe it would actually be best to target this one first because we can figure out what A and C are and then figure out what B is at the end. How about let's take A divided by C equals 7 and multiply both sides by C. And so I could get that A is equal to 7C. This way I could use some substitution actually. Looking at the last equation, A minus C equals 18, I could just replace that letter A with a 7C. And then this way I could just solve for whatever C is directly. 7C minus 1C is going to be 6C. That's still equal to 18. And then 6 times something is 18, so that something has got to be a 3. And actually, I only noticed like after the fact that now that we know that C is 3, we're basically done. Maybe you noticed this too, but this A plus B equals 5 equation, I could put that right here. A plus B is just the number 5. So once I tack on the C that I found, which is 3, I get the number 8. So had I seen that previously, the video would have been a lot shorter, but I didn't on the first time. So I just ended up solving for all the variables, A, B, and C. So cool. We know that the problem works, but you can just kind of follow through with my other train of thought by finishing the whole video. So then I can probably like just kind of look at my other work from earlier and figure out what A and B are. Well, if C is 3, 7 times 3 gives me A, so A is 21. And then I don't actually need to figure out what B is because I already have this negative 13 here. But just for completion's sake, I can see that if I plug in a 3 right here, then B should be negative 16. So I'll just put that here. B equals negative 16. Ultimately, this negative 13 still stands. And so I could say that X is equal to A minus 13, or X is equal to 21 minus 13. And the difference between those two numbers is 8, which matches today's date. So X is 8. And that was solving a system of 3 equations. Cool. We're all done. hope you enjoyed, and I'll see you tomorrow. All right, bye.